So, a solar interconnection is how your solar panel system connects to the electrical grid. You can kind of think of it as a bridge. This bridge lets electricity flow from your solar panels to your home, and it can also send any extra electricity your system makes back to the utility company. This connection is the critical link that really makes your solar investment work. Without a proper interconnection, the power generated by your panels, well, it just has nowhere to go. It's the final, essential step in turning sunlight into usable energy for your daily life, from powering your lights to charging your phone. It's what transforms a collection of solar panels into a functioning power plant for your property. Now, safety is the most important reason for a correct interconnection. Electricity can be dangerous if it's not handled properly. A correct interconnection protects people and property. It prevents electrical shocks, fires, and damage to your appliances. It also protects the utility workers who maintain the power lines. If your system sends power to the grid during an outage, it could actually harm a worker trying to fix the lines. Proper interconnections have safety features to stop this from happening. These safety measures are not optional. They're required by law and electrical codes to make sure everyone, from your family to the line workers, stays safe. Compliance with the National Electrical Code, or NEC, is another key reason. The NEC is a set of rules for safe electrical installations. Following these rules ensures your system is installed correctly and safely. The National Electrical Code, or NEC, is the primary guide for all electrical work. For solar, a few articles are especially important. NEC Article 690 covers solar photovoltaic or PV systems. This is the main article you'll need to know. It provides rules for wiring. It provides rules for inverters. Article 705 is also critical. It deals with interconnected electric power production sources. That includes solar systems that connect to the utility grid. Understanding both of these articles is the first step toward a safe and compliant solar installation. They work together to create a complete picture of the requirements for your system. NEC Article 690 provides the foundational rules for the solar array itself. It tells you how to size wires. It tells you how to select the right circuit breakers. It tells you how to install equipment safely. For example, it has specific rules for grounding the system. It also includes requirements for rapid shutdown. Rapid shutdown quickly de-energizes the solar panels on the roof. This protects firefighters in an emergency. Article 690 is comprehensive, covering the DC side of the system, from the panels to the inverter, making sure every component is installed to handle the unique characteristics of solar power. NEC Article 705 focuses on the point of connection to the grid. This is the interconnection part. Let's look at a common real-world example of applying NEC rules. Imagine you're installing a solar system on a house with a 200-amp main electrical panel. NEC Article 705 has a rule often called the 120% rule. This rule helps prevent the main panel's bus bar from being overloaded. The rule says that the sum of the main breaker and the solar breaker can't be more than 120% of the bus bar's rating. So for a 200-amp panel, 120% is 240 amps. 200 times 1.2 equals 240. If you have a 200-amp main breaker, the maximum solar breaker you can add is 40 amps. 240 minus 200 equals 40. This 120% rule directly impacts your solar system design. If your solar system needs a 60-amp breaker, you can't just add it to the 200-amp panel from our example. You'd be in violation of the NEC. So what are your options? One solution is to perform a supply-side connection. This means connecting the solar system on the line side of the main service disconnect, often called a tap. This type of connection bypasses the main panel's bus bar entirely, so the 120% rule doesn't apply. This is a very common solution for larger solar systems on homes with standard electrical panels, and is explicitly allowed by NEC 705.12a. Another example is the requirement for proper labeling. The NEC is very specific about warning labels. You must have labels at the point of interconnection, at the main service disconnect, and on the solar equipment itself. For example, a label at the main panel might say, "Warning, power source is fed from a remote source." This tells anyone working on the panel that even if the main breaker is off, there is still live power coming from the solar system. These labels are a simple but vital safety measure. One of the most frequent mistakes is miscalculating the 120% rule. Installers sometimes forget to apply this rule or apply it incorrectly. This can lead to a failed inspection and costly rework. For example, an installer might add a 50-amp solar breaker to a 200-amp panel with a 200-amp main breaker. thinking it's okay. But that adds up to 250 amps. The limit is 240 amps under the 120% rule. That overloads the panel busbar and creates a fire hazard. Always double-check your math and confirm panel busbar and main breaker ratings. Another common pitfall is improper conductor sizing. The wires used in a solar system must be large enough to handle the current they will carry. Using wires that are too small is a serious fire risk. Wires can overheat, melt their insulation, and ignite nearby materials. NEC Article 690 provides tables and calculations to help you select the correct wire size. You must also account for conditions like high ambient temperatures, such as in an attic or on a hot roof. These conditions can reduce a wire's capacity, so you may need an even larger wire. Never guess on wire size, always perform the calculations required by the code. Incorrect grounding is another dangerous mistake. A solar system has DC, direct current, components, and AC, alternating current, components. All metal parts must be properly grounded. This includes the solar panel frames, the metal racking, and the inverter chassis. Grounding provides a safe path for fault current to travel, which causes a breaker to trip and shut off the power. A top pro tip is to create a detailed plan before you start any work. A good design plan is your roadmap to success. It should include a one-line electrical diagram, a site plan showing where equipment will be located, details on how the interconnection will be made. The plan should also list all the major components: solar panels, inverter, disconnects. This plan serves multiple purposes. It helps you get your permit. It guides the installation crew. It provides a clear document for the inspector to review. A well-thought-out plan prevents mistakes before they happen and makes the entire process smoother. Communicate with the local utility and the building department early. Every utility and jurisdiction can have slightly different rules or interpretations of the NEC. Don't assume you know what they require. Call them or check their website for their specific interconnection guidelines. Ask about their preferred connection methods. Ask about meter location requirements. Ask about inspection procedures. Building this relationship early can save you from major problems later. A simple phone call can clarify a requirement that might have forced you to redesign after installation. Always use listed and labeled equipment. Listed means a product has been tested for safety by a recognized organization like Underwriters Laboratories or UL. The NEC requires most electrical equipment, including solar inverters and wiring, be listed for its specific purpose. Using unlisted equipment is a major red flag for inspectors and can void homeowners' insurance. To wrap things up, let's review the most important points. First, remember that a solar interconnection is the bridge between your solar system and the electrical grid. Its primary purpose is to be safe and compliant. Safety protects people. Safety protects property. Compliance ensures approval by inspectors. Compliance ensures approval by your utility. Never compromise on these two fundamentals. Every decision you make, from the equipment you choose to the way you connect it, should follow safety and the National Electrical Code. This is the foundation of a successful solar project. Second, focus on NEC Article 690 and NEC Article 705. Article 690 guides the solar system, covering panels covering the inverter. Article 705 guides the interconnection point connecting to the grid connecting to your home's electrical panel. A key rule to master is the 120% rule in Article 705. Understanding these two articles is the minimum requirement. They are the core of solar safety regulations. Third, avoid common mistakes that lead to failed inspections and unsafe conditions. Always double-check your calculations for the 120% rule. Always use the correct wire size for the current and conditions. Ensure every metallic component is properly grounded to prevent shock hazards, and finally, don't forget the labels. The world of solar power is constantly changing, and the NEC is evolving with it. One of the biggest trends is the rise of energy storage systems. Batteries are becoming common in homes. More and more homeowners want to store excess solar for night or outages. This adds another layer of complexity to the interconnection. NEC Article 706 is focused on energy storage systems. NEC Article 690 covers PV systems. NEC Article 705 covers interconnected systems. Future interconnections will integrate solar storage the grid into smart, resilient home energy systems. Inverter technology changes will affect interconnection rules. Smart inverters are becoming the new standard. They do more than convert DC to AC. They can help stabilize the grid by managing voltage and frequency. NEC and utilities are adapting to include these capabilities. Interconnection agreements may specify smart inverter settings. Safety for first responders will be a major code focus. Rapid shutdown rules are an example. Expect refinements and possible expansions. The goal: make de-energizing foolproof in emergencies. As solar grows, protecting firefighters and other emergency personnel is increasingly critical. Industry and code panels are committed to improving safety. Interconnection processes will become more streamlined, making solar more accessible for everyone.